Hi, question in the PhD qualifying exam, University of Montreal, on October 19, 2015. Let G be the subgroup of this general linear group of 8 upper triangular matrices, like that. 1. Give the 5 conjugacy classes and the irreducible characters of G. 2. For every irreducible character G, write G squared as a sum of irreducible characters. We have these 3 reference boxes for this problem. We use DF for this box, JL for this box, and Steinberg for this box. Solution: we write these 2 formulas for the upper triangular matrices. Now we write all the 8 elements of G, and G is the subgroup of this general linear group. Now we want to find the conjugacy classes of the group G. First of all, consider G0. We see we have this one. This implies the conjugacy class of G0 is just G0. Then we consider G1. Then we get those identities. Those identities imply that the class of G1 in G is G1 and G4. Then consider G2. Then we get those identities. So the class of G2 in G is just G2. Then we consider G3. Then we get those identities. So the class of G3 in G is G3, G6. Then consider G5. Then we have this one. This implies the class of G5 in G is G5, G7. We conclude that the 5 conjugated classes are given by those 5 sets. We introduce a theorem to compute the order of the class. This theorem can be seen in this box. So there are 5 irreducible characters of G. Remark: we can use this formula to compute the conjugacy class. Observe the order of the classes. We see that the center Z of G is given by G0, G2. Note that Z is normal in G. So G over Z is a group of the order equals 4. From the order of this one is 2 times 2. G over Z is an abelian group and isomorphic to C2 times C2, where C2 is the cyclic group of 2 elements. Now we can write the direct product of C2, C2 in this form. Let lambda 1 and lambda 2 equals this one. Then from this book at page 81 to page 82, we see that the 4 irreduced representations of C2 times C2 over C are given by those values. So we find the correct table of C2 times C2 given by this table. Now we have this isomorphism, and the center of G is given by G0, G2. So this group is given by Z, G1Z, G3Z, G5Z. We find these identities. So this group equals G1Z times G3Z, isomorphic to C2 times C2. We know for a correct G tilde of G over Z, the mapping G given by GG equals G tilde GZ is a character of G. So we have the correct table of G given by this table. We have the row and the column orthogonality relations. By the column orthogonality relations, we get those identities. From those, we get these identities. So gamma equals C equals theta equals 0. And alpha beta are equal to 2 or minus 2. Out of that, we have this one. And this one implies alpha equals 2. By this column relation, we get this one. This one gives beta equals minus 2. Now, we conclude that the correct table of G is given by this table. Question 2. From the table, we have this one. This one implies G1 square equals G1. From the table, we get those. Those lead to G2 square equals G1. G3 square equals G1. G4 square equals G1. From table, we have these values. So from the table, we get G5 square equals G1 plus G2 plus G3 plus G4. Thanks for watching. Bye.